All right, ladies and gentlemen, here we are. We're in our lesson 8, part 2 now. And in part 2, we're going to finish this activity that's big and important, really important. And I want to walk you through kind of slowly how to do this. First thing it says is, here are 6 different equations, and I want you to look at them. One of them is y equals 4 plus x. The next one is y equals 4x. Then we have y equals 4 divided by x, y equals x divided by 4, y equals 4 to the power of x, and y equals x to the power of 4. And our first question here is, predict which of these equations represents a proportional relationship. So of those equations that you can see, which ones of them look familiar enough, like things we've done so far this year? So put a little star, a little check mark next to ones you predict represent a proportional relationship. It doesn't matter if you get them wrong. Nobody's checking, okay? I just want to see what your thought process is, okay? So look at those 6 equations and put a little star next to the ones you think might represent a proportional relationship. All right, and the next thing we're going to do is we're going to fill out tables of values. We're going to do these repeated things each time the same numbers, and then we'll decide proportional relationship or not. Okay, so we have 6 different tables, and in those tables, you're given values for x, and what we're going to do is use the equation to find out what the y is. So that's our first step. We're going to hold off on this third column for a little bit, okay? The first thing we're going to do is substitute values in for x, and then find out what the y value is, and we're going to do each one of them separately, okay? They're all a little bit different. So the first one says y is equal to 4 plus x. The y value, this value, is equal to 4 plus this value. So 4 plus, if x is 2, 4 plus 2 would give me 6 right here. If x is 3, 4 plus 3 would give me 7 right here. So fill out that table, and then we'll move on to the next one. All right, in our next table, our new equation is y is equal to 4x. And as we've said in class, there's no operation written between that 4 and the x. And when there's no operation there, it means to multiply. Everybody in the math world knows that means to multiply. So our y value here is equal to 4 times the x value. So if x is 2, as we're told here, 4 times 2, sometimes they use little parentheses to represent multiplication, 4 times 2 would be 8. Moving down, if x is 3, I'm going to do 4 times 3 would give me 12. Okay, so you guys fill out that table, and then we'll move to the next one. Fill it out for x is 4 and x is 5. All right, now we'll go on to the next table. The next one says 4 over x. And when we see that 4 over x, that fraction bar means to divide. So we're going to get some decimals here, and that's okay. If I figure this out when x is 2, that means I'm going to do 4 divided by that x value of 2, which will give me 2. For when x is 3, I'm going to take that 4 and divide it by 3. Now I could leave that as a fraction, or I could write it as a decimal. Let me pull out my calculator. Remember that fraction bar means divide. That would be 1.3 repeating, or 1.33333 in my table. Okay, so hit pause and figure out those values, the value of y when x is 4 and when x is 5 for me. Now for our next table, we're doing the opposite. We're taking the x value and we're dividing it by 4. So if x is 2, I would do 2 divided by 4. And I can do that again on the calculator. I can get 0.5. Then I would do 3 divided by 4. And I would do 4 divided by 4. So figure out those values, put them in that middle column for me. Use your calculator. All right, and now we're going to go on to the next one. Now the next one says 4 with a little tiny x above it. That means 4 raised to the power of x. Our y value here is equal to 4 raised to the power of x. That means 4 times itself, whatever number that happens to be, times. So if x is 2, I'm doing y is equal to 4 to the second power. That means 4 times itself twice. So 4 times 4 would be 16. So this would be saying 4 to the second power, which is 16. If x is 3, that's 4 to the third power. That means 4 times 4 times 4. And I can do that on the calculator. 4 times 4 times 4, I think, is 64. And you can see these numbers are going to get really big really fast, right? You do 4 to the fourth for me, so that would be 4 times 4 times 4 times 4. And then 4 to the fifth would throw one more 4 on there. So 4 times 4 times 4 times 4 times 4. You guys do that out for me. Those are big numbers. And then the last one is saying x to the fourth power, which is a little bit different. That's saying take this number as what we call the base and multiply it by itself 4 times. So 2 to the power of 4 would mean 2 times 2 times 2 times 2. 2, 4, 8. That would also be 16. Coincidentally, same number as that one. If the base is 3, 3 to the fourth would mean 3 times 3 times 3 times 3. So that number multiplied by itself that many times, 4 times. I think that's 81. And you can do the same for 4 and for 5 for me. Okay, so fill out those tables. Okay, and now that you've got the tables filled out, that second column filled out, we're going to fill out the third column for each of these. And what it's asking for is, what's the value of y divided by x? So we know what the question's going to be here, right? Eventually they're going to ask us which of these represent proportional relationships, and we know how to find that. We divide y divided by x and check to see if we get the same number each time. So what I want you to do for each of these columns is this divided by this, and this divided by this, and this divided by this, and this divided by this. Write down those answers. And then go to the next table. Do this divided by this, and this divided by this, and this divided by this, and this divided by this. Write down those answers here. And the question's going to be, which of those 6 equations gave us a proportional relationship? And we'll know that because that third column will have either all the same numbers, if it's proportional, or not the same numbers if it's not proportional. Okay, so use your calculators and divide those out. Here were our, and as we turn the page, the question that we're being asked is, do these results, so looking at those values of y over x, do they change your answer to the first question? So remember when we made that prediction about which ones were we expected to be proportional or not? Explain your reasoning. And here's the big takeaway. What do the equations of the proportional relationships have in common? So let's go back and look at those equations. Here were the original 6 equations. And after we've done all of that workout, here's what we notice. The ones that were proportional were this one and this one. The ones that were not proportional were all of the other ones. So here's our takeaway. Proportional relationships we recognize. It's a number times x, or that number, or x divided by a number, which is, if I say x divided by 4, that's the same as saying 1/4 times x, same thing. Any other operations in there? An exponent, not going to be proportional. Dividing a number by x, not proportional, not proportional. X as an exponent, not proportional. Any adding or subtracting, not proportional. Our proportional relationships are y equals, remember we said this, kx. K is some number times x. I should be able to look at an equation and know if it's proportional or not. Any other weird stuff going on in there? Not proportional. A really simple, nice, clean equation, that's proportional. X times some number. And that number, guess what? It's our constant of proportionality. All right, and we'll look quickly at our lesson summary, and then we will be done for Tuesday. All right, our lesson summary: if two quantities are in a proportional relationship, their quotient, remember that's the result of dividing, is always the same. This table represents different values of A and B, two quantities that are in a proportional relationship. And again, we notice if we divide each time, we get the exact same thing. So the way they've written it is A is here, B is here, and B divided by A, this divided by this. Sometimes we say X and Y divided by X, always the same. Notice that the quotient of B and A is always 5. To write this as an equation, we could say B divided by A is equal to 5. If this is true, then B is equal to 5 times A. This doesn't work if A is equal to 0, but it works otherwise. So that's just a lot of blah, blah, blah. If quantity y is proportional to quantity x, we will always see this pattern. Y divided by x, the right divided by the left, will always have the same value. This value is the constant of proportionality, which we often refer to as k, and we can represent this relationship with the equation y over x equals k, or as our more famous equation, y is equal to k times x, so some number times x. Note that if an equation cannot be written in this form, then it does not represent a proportional relationship. So again, anything weird going on in that equation, it's not proportional. All right, that was good, guys. Now we're going to do the practice problems for homework. So starting in your book on page 69, you're going to do practice problems 1, 2, and 3. Let's skip 4. It's complicated. I don't like the question. All right, and that's it. And I'll see you in Zoom on Wednesday. And then we'll get into some fun graphing stuff. And Unit 2 is almost done. All right, take care, guys. Have a good Tuesday.